Welcome to the Gold Newsletter Podcast, your bank of knowledge of investment, economics, and geopolitics. Go to goldnewsletter.com for our publications and archives.
This is Fergus Hodgson at the James A. Baker III Institute on the campus of Rice University. I've got Peter Hartley, originally an Australian, and as far as I know, he completed his PhD at Chicago in economics, yeah. And he has been a long-time researcher in environmental, energy economics, fascinating topics. We're going to discuss the status of energy markets, particularly the evolution of LNG and what its implications will be. So, Peter, welcome to the Gold Newsletter Podcast.
Thank you for being interested in some of my work.
What intrigued me when we just started chatting here, I was just picking his brain and looking for the most relevant topics, was that his belief that the rise of shale gas or LNG in its transported form here in the United States and perhaps in Canada soon, it will cause fundamental changes to world gas markets. I think you mentioned three key changes. Do you want to clarify? So first, what is this development, which is not necessarily a new one, but maybe it's newer in Canada, in the United States and Canada, and how is this going to impact gas markets around the world?
Well, the first thing is what's really changed here is because of the shale gas. So we did have this situation where around about the 2000s, early 2000s, people were expecting the United States to become the biggest importer of natural gas in the world. Natural gas prices in the United States were higher than they were in Europe and even in Asia at that time. And everyone was building import terminals to import LNG, get ready to import LNG in the United States. And we had Qatar, for example, developed extensive gas resources, mainly initially to serve the US market. But those very high prices also stimulated people to investigate new technology. And that's when we developed shale gas extraction techniques were developed. So people had known, geologists had known for a long time that there was natural gas in shale, but it's very low permeability. The gas doesn't flow in the rock easily. So by cracking the rock through fracturing, you allow this gas to be produced. The other key idea is you use horizontal drilling. So you have the well that stays in the layer of shale for a very long distance. So you have a lot of rock that's exposed to the well, and that increases the production, makes it economic. And the other factor was the use of what's called proppants. So you put sand in there to keep the cracks open. So these three things, hydraulic fracturing to cause the cracks, the horizontal drilling to give you more exposure to the rock, and then the sand to keep the cracks open. This was all stimulated by the high price, but it was so successful that, the United States has now become the biggest producer of gas in the world, and also it's now gone into oil, of course. So there's a whole set of issues about how the oil market's changing as a result of this. But there's been a tremendous change in the gas market because of that. Now you've got all these projects being built in the United States to export natural gas to the rest of the world as LNG.
Do you want to just give us a few numbers? So let's say we were to go back either 10 or 20 years. Was it just zero? I mean, how much natural gas was coming out of shale at that time?
You didn't really have any coming out of shale until they developed these techniques. And initially, it was George Mitchell Energy, first showed that it was economic, working on the Barnett Shale in North Texas, which is basically around Dallas-Fort Worth area. And I think that Mitchell Energy drilled 23 wells, something like that, before they got one that worked. They had to try all these different techniques, and then eventually they found the one that worked. He was confident that he could get this to work, and eventually proved it could be done and done economically. And since then, we've had this technique has spread all through North America, and now actually Argentina is now starting to produce shale gas, and probably will go elsewhere in the world. There's probably lots of opportunities. But the first instance has just been tremendously successful here in North America. And as a result, prices here, gas prices, came to be the lowest in the developed world, from the highest just about to the lowest. People saw this real opportunity. If you could get that gas from the United States, sell it in Asia where the gas prices are very high, you can make money doing that. So initially they were the terminals that are going to be used for imports. They turned them around to be to be export terminals. So you bring in the liquefaction. You've already got the pipeline connection to the rest of the market. You've already got the port works that have been done, the dredging that's needed to get the LNG ships in. Relatively cheap to put in liquefaction facilities, to put in those terminals in the United States, compared with a complete greenfield project in some remote area of northwest Australia or Papua New Guinea or Africa, which is where people were building plants. Much more expensive to do that than to turn around one of these import terminals in the United States.
You said the United States has a very handy position with access to Europe, South America, and Asia. So there's a great deal of potential for arbitrage. Now, was that one of your three big impacts?
Yes. One of the big three impacts is the geographic position of the United States. So they're able to easily sell LNG into markets in Europe and Latin America and via the Panama Canal to Asia, particularly via the Panama Canal. And of course, the widening of the canal has allowed bigger ships to go through, including the bigger LNG ships. So it's made it much more economic for the United States to access the Asian markets via that. Prior to this, Qatar was in a situation where they could sell LNG either to Asia or to Europe. From Africa you probably could, but from Southeast Asia and Australia you really couldn't. I mean, you were basically selling into the Asian market, very expensive to access the European market. Number of companies that could ship either direction and arbitrage those prices was limited, but now you introduce all these US firms, they can do that. So that's one of the big impacts, I think, of this change.
Yes, so that just means that we will see a more uniform price level around the world and the United States enjoying the differences that have been available.
Well, the other thing is that a couple of other factors that influence that, which is that, the United States is the biggest gas market in the world, really. And you have all of these derivative contracts, futures contracts and then options contracts that are based off Henry Hub prices in the United States. And on top of that, you've got a huge amount of storage in the Gulf Coast for natural gas in salt caverns and, to some extent, previously exploited natural gas fields. And, of course, the United States has also got the ability to import LNG as well as export it. So you've got the ability to import LNG, you've got the ability to store gas, you've got the ability to export. So not only have you got this geographic arbitrage opportunity, you've got intertemporal arbitrage opportunity. So, if the gas price, if the world, it'll put a floor on LNG prices in a sense, because if the world LNG prices get very low, you can always import it into the United States and store it. And then you've also got a ceiling because if the price in the rest of the world gets very high, you can take gas from the United States, liquefy it and export it. So, and then you've also got this ability to hedge risks in this US market with all these derivative contracts and so on. So this means that natural gas becomes a much more traded commodity, a much better arbitrage market. You've got more financial contracts and so on to manage risks. And so this is a big game changer, I think, in terms of the world market. On top of this, I mentioned that at least these initial facilities were built by turning around regasification plants, adding liquefaction to the regasification terminals. That means that they're much cheaper than building a greenfield project in a remote location where you don't have a lot of workers, you don't have a lot of trained workers and so on, so very expensive. Because they are less expensive, you don't need as much debt finance to finance them. And because you don't need as much debt finance, you don't have to have bankable contracts, long-term contracts for the sale of the LNG at the other end, which means that much more of the anticipated output can be kept open to spot trading and flexible trading, and so you can send it to different locations, but also you can take advantage of these intertemporal trading opportunities like I'm talking about. So the fact that you don't have to have these long-term contracts to underwrite the debt financing for the capital costs leaves you in a situation where you're able to exploit this optionality, these real options. It gives you a very different trading frame. And something that's going to I think, increase the connectivity between gas markets in different parts of the world and increase the stability of natural gas prices.
Yeah, so that second element, let's say that the relatively low capital input for the U.S. production facilitates even further that buffering capacity that the United States has.
The other aspect of this is that We've got to think about LNG. Liquefied natural gas, I should really back up. Liquefied natural gas is not actually a fuel by itself. It's really just a way of transporting gas. So you have gas in the United States that's produced and put into pipelines. If you want to carry it across the ocean, it'd be very, very expensive to build a pipeline under the sea for a very long distance. So what they did is by cooling the natural gas down to minus 163 more or less degrees Celsius, it becomes liquid. And you can then put it into LNG ships. You reduce the volume, by making it liquid, you reduce the volume by a factor of 600. So it becomes much more energy dense. It's then worthwhile transporting it long distances, you see. You do that in specialised ships, these LNG carriers, which are basically like sort of like floating thermos bottles, really. So you ship it as a liquid form, and then at the other end you turn it back into gas, into a regasification plant, and then the gas is put into either a pipeline or used to produce electricity or whatever. So anyway, LNG is basically a way of enabling you to transport gas long distances. But another important thing about LNG is if you're a buying country and you have a regasification terminal, basically you can buy that liquefied natural gas from anyone who's producing it. It's very different from pipeline gas. So if you're Germany, you have a pipeline connection to Russia, basically you're stuck to buying from Russia. They're your main source of supply. But with you've got liquefied natural gas, you can buy from lots of potential suppliers. So this is another sense in which an increase in LNG trading worldwide, it's another implication it has for world gas markets, that it changes the strategic element. I had a graduate student, Canadian graduate student, Natalie Hinchy, just graduated in December last year. In her PhD dissertation, one thing she looked at was this terminal in Lithuania. So they put in an LNG terminal to import. They called their terminal, interestingly enough, Independence. Because one thing it did was it gave Lithuania the ability to be independent of Gazprom. So before that, 100% of their natural gas came from Russia, from Gazprom. And Natalie showed that if you have more sources of gas, if you're a European country with more sources of gas, it improves your strategic bargaining position vis-a-vis Russia, and you had a lower gas price. So she calculated how an increase in competition, what it did to your gas price from Gazprom. And what she showed is basically that by putting in the terminal, Lithuania was able to get a lower gas price from Gazprom, and the lower gas price basically paid for the cost of the terminal. So having seen this, we've got Poland putting in a terminal, we've got Ukraine talking about putting in a terminal, and various other. So LNG also has this geopolitical or strategic kind of implications as well.
Can we say that these geopolitical implications, or the implication is that there's just maybe less consolidated power in the industry with some countries, and it's basically decentralized it?
Yeah, it's made it more into a genuine market where you have many buyers, many sellers, prices being arbitraged, the ability to use financial contracts to manage risks, all of these kinds of things.
Every month, for nearly 50 years, Gold Newsletter has unearthed high-potential investment opportunities in metals and mining stocks that mainstream investors didn't even know existed. The value and profit potential we pack into each and every issue of Gold Newsletter make it an absolute steal at just $198 per year. Your subscription includes 2 special reports, Money Multipliers, resource stocks poised to triple, and The Investor's Guide to Gold and Silver. To subscribe, visit www.goldnewsletter.com and click subscribe now to discover how to multiply your returns in today's gold bull market.
And you see the big beneficiary is the consumer, right?
Yes. The other interesting thing that we probably should talk about here is, in addition to sort of the LNG market, we've got natural gas is growing and is expected to grow as a proportion of final energy consumption. And there are a number of reasons for that. I mean, one is natural gas is the cleanest burning fossil fuel, so it's much less polluting. People get more concerned about environmental issues. There's pressure to use more natural gas. But the other thing is, it turns out natural gas is very useful and efficient as a way of generating electricity. The first thing is that the development of what's called combined cycle power plants really improved the competitiveness of natural gas as a fuel for generating electricity. So what happens with a combined cycle power plant is you burn the natural gas through a turbine, and then you use the hot exhaust gas to boil water, make steam, and then you put the steam through another turbine. So basically these plants are about 65% efficient. 65% of the energy gets converted into electricity. So it's made natural gas a favourable fuel for electricity generation. In addition, these plants tend to be lower scale than something like a coal plant or a nuclear plant, so they're less risky for the utilities to put in a gas plant. The second thing is you can use natural gas purely in gas turbines as a backup source of power. So the thing is you can start up a gas turbine very quickly, and you connect to the pipeline, you've always got to supply gas. So if you need to supply electricity very quickly, you can use a gas turbine to do that. And it's important in electricity systems, you have to keep, a lot of people don't understand, you've got to keep supply and demand precisely balanced all the time, or you have problems with the quality of the power. Frequency changes, you can even get blackouts, the whole system goes black. Natural gas is really good for always ensuring the system's balanced. This has become much more important with countries putting renewables on the system, because wind and solar, both of them can fluctuate, the output can fluctuate a huge amount over a very short period of time. So you need some backup to keep the system stable. And so the fact that natural gas can provide that backup at low cost and with low pollution output is, in many, many cases, the only reason why we can even include wind and solar on the system. If you didn't have some way of balancing them out, you couldn't really do it at all.
Because natural gas is storable and space efficient, dense option if it's stored correctly. I know this is an awkward question, but from the investor's perspective, does this all mean what you've been explaining to me, that natural gas is going to continue to grow, or the extraction of it is going to continue to grow in the United States and perhaps Canada too?
Yeah, I think it is going to continue to grow. The other thing about natural gas we didn't talk about is very important really important in Canada, but also in northern parts of the United States, to some extent Asia, but also Europe, is, of course, a lot of natural gas is used for space heating, indoor space heating, right? So your very cold winters and so forth, it's really important. In the United States, basically, there was a small amount of heating oil is still used for space heating, but very substantially natural gas has displaced that. But there's still lots of parts of the world that are very cold, where, like in China, they're still using coal for indoor space heating. Very, very polluting. That's one reason why you've got very heavy pollution in a lot of Chinese cities. So the Chinese government is trying to switch towards natural gas for space heating. So you think about a lot of places in the world, there's still opportunities for using a lot more natural gas for those purposes. And another really important use of natural gas is for industrial use, making plastics and fertilizer and petrochemicals more generally.
How ubiquitous is natural gas, and particularly this shale revolution, if we can use that term, I've heard it before? Are other parts of the world just going to catch on and replicate the United States' efforts in this regard?
So this has been something that people have been very interested for a long time. There's certainly other parts of the world that have shale, that have gas in it, and the properties of the shale are similar to US shale, some of the US shales. There are various things that were important in the shale revolution taking off in the United States. So it's not just having the rock. It's having a very sophisticated oil and gas production industry, E&P industry, where you need to have these sophisticated rigs that can do this horizontal drilling and so forth. You need to have trained workers who know how to do that. There's a lot of high-tech equipment is used in this industry. People don't realize how high-tech it is. You need to have good surface transport infrastructure. You've got to get the water in. You've got to get the sand in. You need to have a well-developed pipeline network to get the gas out. And you need to have pretty good understanding of the geology. So there were lots of things that were really important that made this take off in the United States.
Because the United States had both the technology and the manpower, and maybe a sufficient nexus of both to get some momentum. And that's not going to come anywhere else easily or right away.
And you had all this transport infrastructure that you needed, as I mentioned. And another really critical thing in the United States was the property rights. So most of this unconventional oil and gas development in the United States, almost all of it has been on private land, not public land. And the private landowners in the United States own the mineral rights. So they had an incentive to go with the oil and gas companies to help them develop these resources because it was money to them. And so, they can have very small, at the end of the day, when you actually done all the work and have the well operating, it's just a small pad area, maybe enough grass to feed one cow, but you get a lot more money off that area than you would get from one cow, basically. And so the landowners had this incentive, their incentives were aligned with the oil and gas companies, and so they supported the development. Whereas in a lot of other countries, one problem is the government owns the mineral rights, the landowners don't get anything out of it. All they get's some inconvenience, from these companies coming in, and so they tend to oppose it rather than supporting it. So that's another thing that was sort of really important here, was the institutional framework.
So the structure where in the United States the land below your property was yours too, and so there was an aligned stakeholder to push for it, whereas I don't know what it's like in Canada. Is it the same there?
No, mostly I think Canada is like most other countries, mainly the government owns, but I'm not sure about that. I know that this is the case in Australia, that the minerals are owned by the government, and it's led to problems with hindrance to the development of unconventional oil and gas. There's certainly lots of indications that a lot of it's available. And in the case of Australia, in fact, you had the development of what's called coal seam gas or coal bed methane, same thing, which is also unconventional form of gas. It got going in Queensland, a lot of small companies too. That's another thing about the United States. You had a lot of these small companies. I mentioned Mitchell Energy. So the companies that got into this in the first place were small, private equity companies. They did a lot of the experimentation. They proved it could work. Then what's happened is that a lot of them have been taken over by the bigger firms coming in. But it's interesting that Australia also had a lot of small companies, and it was a lot of the small companies that developed the coal seam gas, and that's what the LNG plants in Queensland basically are based on. But then what happened in Australia, the environmental movement, the Queensland kind of got away from them. It was developed there. But then, there's a lot of natural gas in New South Wales.
Western Australia, I assume.
It's already been developed. That's true too. But in terms of, I'm saying the unconventional, there's a lot in New South Wales and Victoria. But the environmentalists basically stopped development in those states. And because the government owns the mineral rights, you didn't have the same alignment of landowner interests that you had in the United States. So it's been less successful.
That is peculiar, the way you said the environmentalists are stopping it, because as you said, it seems like natural gas is such, at least it's a non-renewable resource, but at least while it's being used, it's a cleaner option. Not only is it cleaner in terms of the burning of it, but in its transportation. Before we were discussing the way that pipelines, which many environmentalists have opposed, you said the Keystone XL, and there have been others in Canada, would have actually been the environmentally safer options. How has this come to be that the safer or the environmentally friendlier option has been railroaded in places like Canada and Australia?
Well, now you sort of get into the oil market, which is another issue. But the basic idea is, I think there's opposition to fossil fuels, really. But people don't really understand a lot of the complications of energy markets. And so, like I mentioned, there's different kinds of fossil fuels. So, natural gas is the cleanest burning fossil fuel. But also, it's really critical at the moment for backing up renewables, which is what the environmentalists want. But they seem to think, okay, what we should do is go to renewables plus batteries. We don't want any fossil fuel at all. But they don't understand that, first of all, it's very, very expensive to try to do that with batteries right now. And the tremendous amount of mining that would be necessary. A lot of these batteries are using nickel and cobalt and lithium. These things be hundreds of times the amount of this material would have to be mined and so forth. So extremely costly. Also, you can't really store electricity for a very long period of time. Lots and lots of impractical things. People, the average person doesn't even realize that you have to, in running an electricity system, you always have to have very finely balanced supply and demand. They just sort of think, oh, well, wind and solar, that looks like it's non-polluting, the energy's free, it's much better. But they don't understand there are technical properties of the generators that it's a very sophisticated system. Talk about the XL pipeline, I guess, which part of the story there is again, people are trying to stop the exploitation of unconventional oil by controlling the pipeline. But if you stop pipeline as a way of transporting oil, you don't actually stop it being transported. You force it to be transported by truck and rail. And then if you have the probability of an accident is much higher, the probability of spill is much higher, the environmental damage is much higher. So really it's kind of a strange way of trying to stop fossil fuels, I think.
And you say your assessment is that there's just this maybe blanket negative reaction or knee-jerk reaction to any fossil fuel, even though natural gas is the cleanest of them all.
Yeah, that's, I think, essentially the idea that, initially a lot of environmentalists supported natural gas on the grounds it was cleaner burning. And indeed there were, some of the big energy companies that have a lot of gas resources were going in with Sierra Club and people like that to promote natural gas. But once the United States had a lot of it, and the United States was becoming a big, my cynical view, I think a lot of the more radical environmentalists actually are anti-capitalist, anti-market.
Sure.
And once the US has got the resources, they became anti those resources.
So it was maybe the negative association with the United States as the big bad capitalist nation. That simplistic?
When the United States was going to become the biggest importer of gas in the world, natural gas is going to become expensive. The US didn't have it. Environmentalists seem to be pro-natural gas. Now we've got it, they become anti-natural gas. So it is kind of interesting. I don't know what's going on. Who knows what's in these people's heads. But the fact of the matter is, I think that everyone knows at the end of the day we're going to transition off fossil fuels at some time, but that transition is going to involve the use of a lot of natural gas in the interim, and I think that's inevitable.
Where can people get your research, aside from the Baker Institute, which is just bakerinstitute.org, as far as I know?
Well, there is actually, Baker Institute has a Centre for Energy Studies, which has been voted by people in the industry as the top energy think tank in the world. They can go to the Centre for Energy Studies at the Baker Institute, and there are a lot of working papers there. And you can also get copies of working paper copies off the Department of Economics website here at Rice University.
Actually, that's true. If you go to the Baker Institute website, there are specialized releases by area, topic area within the organization. And you personally are not really a social media man, let's put it that way.
No, I'm not actually. I haven't really been on podcasts and things like that. I have enough trouble keeping up with email.
Don't we all? This is Peter Hartley of the Baker Institute. Mate, thanks so much for your time.
Well, you're welcome. Thank you very much for your interest in my research.